Hi, and welcome to Ivy English. I'm Karen.
And I'm Chris Gorski.
Today is Chris Gorski with a little kind of a thing in your voice.
Yes, it is. Well, welcome to 2024, and I suppose this is what happens when you
Party too hard.
That's right. You enjoy your celebrations. You blow your voice out.
Okay, so today is January 2nd. We're on page 10 in your magazines. And today we're going to talk about the sublime effects of dry ice, which is kind of a pun.
That's right. To sublime is a terminology from chemistry or even physics where you have a solid turn immediately into a gas and it skips the liquid state. So dry ice, if you know what it is, the Chinese is exactly the same. Mm-hmm. It's a block that turns into a gas. And it's pretty fun to play with if you know how to be safe.
That's right. And the first time I saw it, I did find it amazing because if you're just used to regular ice, you got a pool of water first, but you don't get that with dry ice.
No, you don't. And in fact, the eerie smoke, quote unquote, that comes off it, it just captures your imagination as a child. And when you have a parent or an adult that can just show you all sorts of mischievous tricks that you can do with dry ice, it just becomes all the more interesting.
It's sort of like when you first learn about mercury.
Yeah, mercury is a little more dangerous, though.
It is. It is. Well, let's get to our article. Our title again is The Sublime Effects of Dry Ice. Sublime, as Chris just said, refers to a physical process of going from a solid directly to a gas with no intervening liquid stage. But sublime has another meaning. It means it's so wonderful. So how do you like this cake I baked?
Oh, it's sublime.
Sublime. It's so good.
That's right. It's really, really top tier good.
Okay. Dry ice is a remarkable substance with many versatile uses. It might look like a simple block of white-colored ice, but this could not be further from the truth. While regular ice is the solid form of water or H2O, dry ice is the solid state of carbon dioxide or CO2. Temperatures must be incredibly low to freeze carbon dioxide gas into a solid form. This unique property makes dry ice ideal for tasks such as flash freezing produce, keeping foods cold during transit, and even removing moles from people's skin.
One of the most notable physical characteristics of dry ice is its ability to sublime. Sublimation is a phenomenon in which a substance transforms from a solid state directly into a gaseous state without becoming a liquid. In the case of dry ice, this occurs at the frigid temperature of minus 78.5 degrees Celsius. If carbon dioxide falls below this point, it transforms into dry ice. Conversely, when it is above this temperature, it transforms into CO2 gas. Due to its extremely low temperature, dry ice can be dangerous to handle and can cause severe skin burns if touched without proper protection.
When dry ice is combined with water, it produces an interesting reaction. If you place it in a bucket of water, the carbon dioxide will react with the water and produce gas bubbles. As the gas bubbles reach the water's surface, they create a thick fog because of the extremely cold temperature of the dry ice. The fog is much denser than the surrounding air, so it normally sinks to the ground, creating an eerie sensation. Therefore, dry ice is the perfect addition to any haunted house. Now, this isn't really Halloween season, but you can keep it in mind for October.
We used to have it was actually an old grenade chest from World War II. My dad purchased this at a military surplus store where the military will basically just give certain items away, and some companies will resell them to the general public. And these items might be uniforms, they might be tools, nothing too dangerous. And we had this old World War II chest, and he painted it spooky colors, and every Halloween, he would place a bowl of dry ice in there, and there was like a creepy hand he somehow rigged a scary hand to come in and out of it. And so it was really scary. It was pretty cool.
Yeah, and he did it himself because a lot of people now buy these ready-made from a store, And they look kind of tacky.
Yeah, they have that plasticky kind of sheen to it. Yeah. And to be fair, the hand was made out of plastic, but there was a creepy light bulb in it. There was it was burned wood, and then he tarnished it with some colors. I remember it was really fun. And because the box at that point was already some 40 years old, it was really quite decrepit and falling apart. So do it yourself, and dry ice will really send it home.
Very good. Okay, back to the beginning, the sublime effects of dry ice. Dry ice is a remarkable substance with many versatile uses. Now, the key word here is versatile, and it might be versatile in British English. It means it has many different uses. You can take the same thing and use it for many different purposes.
So substance is a very specific term in science. When we talk about substance, we really just mean like thing, but in science, we're talking about a particular kind of matter. These have uniform properties. Every bit of dry ice you might sample from around the world will all act the same.
Okay, our next sentence. It might look like a simple block of white-colored ice, but this could not be further from the truth. And this brings me back to elementary school when a teacher brought dry ice to class and told us about it. It was just so different. It was just so shocking the way it was behaving. Just wasn't what you expected.
Do you remember what your teacher put the dry ice in order to keep everybody safe? Do you remember what kind of container? What was it made out of?
Honestly, I don't remember.
Yeah, to me, it was always styrofoam for me as a youth.
I think it was. I was thinking styrofoam. Yes.
Before styrofoam, they would use like cast iron, but that had the bad habit of, exploding. And it would create shrapnel. It would kill people.
Yeah.
And so before the creation of styrofoam, they would have to use cast iron or wrought iron, which is incredibly heavy and not nice to touch, honestly. So it was one of those things, just like, what did people do in the meanwhile? You could use ice, I imagine, or wood, right?
I suppose, but now that you mention it, I was thinking styrofoam anyway, and I think that's usually where you will see it. Okay, so it may look like ordinary ice, but it really is not like ordinary ice at all. And there are especially some safety concerns you have to keep in mind. You can also get frostbite from regular ice, but this one is much, much worse. So while regular ice is the solid form of water or H2O, dry ice is the solid state of carbon dioxide or CO2. Okay.
That's right. So regular ice, it's water, right? So when it melts, you're going to have a puddle of water. Dry ice actually is quite useful in modern times for degreasing or construction, for deep cleaning surfaces, or even restoring old paintings or buildings. So they create little pellets. So they take like a hunk of dry ice and they shred it into these, I suppose, little daggers. And then they fire it through a high pressure nozzle. And because it strikes it so fast and so hard, number one, it knocks off big chunks of dirt and grime. But also because it's so cold, it flash freezes grease and grime that you want to remove, and there's no melting whatsoever. So there's no water. And interestingly, because it's so cold and your regular surfaces are not that cold, there's a thermodynamic transfer here. So the heat from the surface immediately transfers into the hunks of dry ice. Yeah. There's a molecular explosion that takes place.
I was going to say.
That's right. It literally blows off the dirt. Yeah. The only problem is it's kind of expensive relatively to like water pressure. But for delicate and important processes like dry ice cleaning, it's called dry ice blasting. It's really incredible to watch them just clean like a carburetor or something.
I learned something. I never knew about that. Okay, so we have a different element here. Well, it's a different compound. It's CO, carbon, and plus 2 molecules of oxygen, and it behaves very differently. Let's keep going. Temperatures must be incredibly low to freeze carbon dioxide gas into a solid form. And this is very straightforward. We've already discussed that. This unique property makes dry ice ideal for tasks such as flash freezing produce, keeping foods cold during transit, and even removing moles from people's skin. Now, that last one I did know about. So if you have produce that you want to freeze very, very fast, you can use dry ice because regular ice will take longer and it will melt. And if you want to keep things cold during transit, again, regular ice melts and you have a puddle of water, but you can put this in styrofoam containers and then keep the foods very cold when you're taking them, for example, by truck from the grower to the wholesaler or the supermarket.
So a mole is the black dot that you get on your skins. If you look at light-skinned white people, you will see a lot of moles on their body. I have a lot. My sister has red hair, and she's covered in moles.
Let's go on to the next paragraph.
One of the most notable physical characteristics of dry ice is its ability to sublime.
And we already know what subliming means. As an adjective, it means really wonderful. But as a verb, it means what we just said, to go directly from a solid to a gas with no liquid state in between.
Now, we can also do the opposite. Gas immediately to solid while skipping the liquid phase is called deposition because you literally deposit crystals on a surface. Probably the way you best know deposition in everyday life is a frosted windshield. Like when we wake up in the morning and back home, your car window has a layer of ice, and those were frozen on the surface through deposition. There was no liquid. It went immediately to solid.
I learned something. I didn't know that. Okay, let's continue.
Sublimation is a phenomenon in which a substance transforms from a solid state directly into a gaseous state without becoming a liquid.
And we've said this a number of times now, but I can add one more point, and that is there are two ways to pronounce this word. It can be either the way Chris says it as gaseous, or you can say gaseous. And I think my initial thought was to pronounce it gaseous, but if I hear somebody say gaseous a lot, I will probably go along with that.
Interestingly, I actually wrote that you have two pronunciations here because I know my own pronunciation best. I wrote it down as a note to remind you guys. This E-O-U-S might have that sh sound. So whatever you prefer, make sure you write it down because the word is not, I don't think it jumps off the page as something easy to read.
No, it doesn't. And there's a similar word, and that's nauseous. Some people will say nauseous. It's less common.
Yeah, I say nauseous with that consistent sh, yeah.
Nauseous.
Yeah.
Oh, I say nauseous with voicing. But in any case, watch out for that ending. There may be more than one pronunciation. Pick the one that you hear the most people using. Or go to Merriam-Webster and use the first one.
There we go.
Okay. You may not hear people using the word gaseous every day.
So phenomenon is just a fancy word that means thing that happens. It's a word that you will see really regularly if you enjoy reading articles about things that don't happen every day. So it's a common word about uncommon things. Please practice the word phenomenon. It's a little tricky.
The other thing that's quite tricky about this word is it has an irregular plural. So phenomenon is the singular. Phenomena is the plural. But in English now, a lot of these irregular plurals are becoming regularized. So we used to say bacterium, bacteria. Now bacteria is treated as a singular.
Yeah, I'm trying to think if I have heard someone say phenomenons with
I
an
didn't
S.
say phenomenons. However, when I was doing my oral defense for my PhD, I said phenomena when I meant to say phenomenon. And then I thought, that's now recorded, and I've heard it many, many times by other people. So a lot of people mean to say phenomenon, but they say phenomena.
I'm thinking of the Gen Zers I know because they have their own characteristics. And I'm trying to think, like, because you often bring these up, these irregular nouns or how these words have been changing over time.
Yeah.
And I try to think of the next generation after me. What are they saying? How are things being handled by them?
Things are definitely changing. And I've been hearing S's on animals that tend to live in packs. So there are lots of deers in the picture.
Yeah, I've heard.
It's
I
been
just
getting
had
really
this conversation.
common.
Yes. I was like, who says deers? And
And
this was a new one to me.
Okay, they still should not have an S at the end. They are actually plural. The singular and plural are the same form, but it seems to be changing.
Okay, let's go to our next sentence here. In the case of dry ice, this occurs at the frigid temperature of minus 78.5 degrees Celsius. Karen, I'd like to ask you, when you see the symbol here, do you want to say minus or negative here?
Neither one. I say it's 20 degrees below zero.
That's it.
That's the way we say it in Minnesota. It's 40 degrees below zero, and we all use Fahrenheit. Nobody even thinks about Celsius. But when you're reading it across like this in an article, I would read it just like you read it. So minus 78.5 degrees Celsius. Remember that. So the next time you have to read it, you'll be ready.
Okay, if carbon dioxide falls below this point, it transforms into dry ice. And let's go to our next sentence. Conversely, when it is above this temperature, it transforms into CO2 gas.
And that's basically been repeating what we've been talking about since the beginning of the lesson. So if it is any warmer at all, and warm is a funny word here for minus 78.5, actually, it does not sound impossible to me coming from Minnesota. We haven't gone down that low, but 40 degrees below zero Celsius and Fahrenheit is the same at this temperature. You go further below, and then you will get that further up north in places like Alaska and going towards the North Pole. It's not something I can't imagine. And I've been to Siberia. And I know that if you dress very, very carefully, you can still survive. But it's extremely cold. Don't try it.
Let's go to our next sentence. Due to its extremely low temperature, dry ice can be dangerous to handle and can cause severe skin burns if touched without proper protection.
And our teachers instilled the fear of God in all of us. We were all very, very careful with dry ice and I believe with mercury as well. I didn't know right away that it was so poisonous.
There was a video discussing various things you can do with dry ice, and one of the ideas that they suggested was at a kid's party, you put little chunks of dry ice in their drink because this is CO2 gas. It's essentially soda pop, right?
Right.
However, drinking a piece of dry ice would be disastrous. Number one, you're going to be very bloated. Number two, if it touched the sides of your esophagus or throat, you're going to literally burn sections of your skin. Putting this in a kid's drink sounds like a disaster to me. Maybe if you had a chunk of it in the bottom of a punch bowl or something.
In the punch bowl,
That's
maybe.
Right. Yeah.
Right. Then your voice would really have been burned out. Seriously. Let's go on to the last paragraph. When dry ice is combined with water, it produces an interesting reaction. This is very straightforward. We don't know what that reaction is yet, though. If you place it in a bucket of water, the carbon dioxide will react with the water and produce gas bubbles. Now, that sounds kind of something that you could imagine. So it's melting very, very fast and producing gas bubbles. As the gas bubbles reach the water's surface, they create a thick fog because of the extremely cold temperature of the dry ice. So when it hits the air, then you've got this fog, and that's the stuff that we like to use in stage productions and concerts and things. The fog is much denser than the surrounding air, so it normally sinks to the ground, creating an eerie sensation. So if you are steaming something in the kitchen, the steam will rise. It's hot. But in this case, what looks sort of like steam will fall to the floor.
Now, eerie is a nice adjective meaning creepy or scary. I suggest you write down the adjective creepy here. C-R-E-E-P-Y. Eerie and creepy are words you will see very regularly in the month of October, especially in the lead up to Halloween.
Exactly. And our last sentence, therefore, dry ice is the perfect addition to any haunted house, assuming that you are exercising the proper precautions. So we have a few questions for you. Number one, what happens in the process of sublimation?
A gas becomes a solid.
Nope. B, a solid becomes a liquid. No, we have no liquid involved.
That's just melting. Letter C, a solid becomes a gas.
And that is our answer. D, a liquid becomes a gas is also wrong. Number two.
Gina is working on a report about dry ice. Which of the following pieces of information is not correct?
So it says which one is. There's only one answer, apparently. A, dry ice is the name for CO2 in its solid state. True or false?
Well, that's true.
So we don't want that one.
Letter B, if not handled properly, dry ice can pose safety risks.
And that is absolutely true. That's the first thing probably we learned about it. So B is not the answer. C, dry ice can be used in various ways, even in the medical field. And Chris did a really clear firsthand description of what happens when you use dry ice to get rid of a mole.
That's right. In fact, it was also very useful during the vaccine transfers. It was all dry ice.
Oh, okay.
Letter D, when the temperature drops below minus 78.5 degrees Celsius, CO2 becomes gaseous.
No, it becomes a solid. So D is incorrect and thus is the correct answer here. Number 3, why does dry ice form a dense fog when it is blended with water?
A, the dry ice turns into a solid ice block.
That is wrong. B, the dry ice causes the water to dissolve, forming water vapor, okay? You don't cause water to dissolve. All right, that's wrong.
Letter C, the temperature of water is far colder than that of the carbon dioxide.
And that is really not true. D, the combination creates cold CO2 bubbles that turn into fog on the water's surface. That is the correct answer. And that is it for today. Tune in next time. We'll see you then. Bye-bye.
Bye-bye.